Hello everyone, and welcome back to the channel. In today's tutorial, we're going to dive into creating a realistic road material using Blender's shader editor. We'll apply this material to the procedural road we created in the previous geometry nodes tutorial. If you've followed that video, you should already have a basic road mesh generated using geometry nodes. If not, no worries. I've linked that tutorial in the description below, so you can catch up at any time. To begin, you'll see the node setup we used to create the road in geometry nodes. On the side, we also have the nodes responsible for the lane markings. But for now, let's keep things simple by disconnecting the lane marking nodes so we can focus solely on the road surface. We'll assign a material to the road by pressing F3 and adding a Set Material node in the Geometry Node setup. In the Material tab, click New and rename the material to something like Asphalt Road Material. With that done, we're ready to work on the material itself. Let's turn off scene lighting for now to better focus on the material's appearance. Next, switch to the shader editor. You should see the default principled BSDF shader. Select it and press N to open the side panel. If you've enabled the Node Wrangler add-on, you'll see a section called Add Principled Setup. If you don't see it, go to Edit, Preferences, Add-ons, search for Node Wrangler, and enable it. For the road material, I'll be using the Asphalt 023C texture from Ambient CG at 2K resolution. Since our road is procedurally generated using geometry nodes, it doesn't have UV coordinates by default, so we'll need to create them manually. To do this, go back to the Geometry Nodes workspace and press F3 to add a store-named attribute node. Set its type to vector and the domain to face corner, which is important for proper UV mapping. Name this attribute UV road. To define the UVs, we need to generate X and Y coordinates. For the XU axis, we'll use the curve's parameter value, which gives a range from 0 to 1 along the curve's length. Add a capture attribute node, this will be used as the U value. Combine the U and V values using a combine XYZ node and connect it to the input of the store-named attribute node. However, since the X and Y dimensions aren't equal, this can cause texture stretching. To fix that, add another capture attribute node. Use a curve length node to get the actual curve length. Then multiply the factor by this length to get a consistent Vy value. Combine the U and V values using a combine XYZ node and connect it to the input of the store-named attribute node. Now that the UVs are set up, return to the shader editor. At this point, your road texture should map correctly and consistently along the mesh. To enhance the look further, you can blend this asphalt texture with an overlay, such as procedural dirt. Add a mixed color node, set the blend mode to multiply, and set the factor to 1 for a full effect. Now let's bring back the lane markings. Reconnect the lane marking nodes you previously disconnected in the Geometry Nodes editor. Then, assign a new material to the lane geometry by adding another set material node right after the node group that generates the lane mesh. Create a new material in the Material tab and rename it to Asphalt Road Lane Marking. Back in the shader editor, select the lane geometry object to work on its material. In the Asphalt Road Lane Marking material, add another mix color node. You can again use the Mix Blend mode to combine a base color or texture that represents painted stripes or road symbols. Next, let's add some black tire markings along the X direction of the road. Go back to the Geometry Nodes editor and capture the X-axis values. To do this, select the store-named attribute node, duplicate it using Shift-D, and plug the X-axis value into the new node. Set the name to UV_RODX and set the domain to point. Then head back to the shader editor add an attribute node and type in UV_RODX as the attribute name. When you preview it using Shift plus right-click, you should see a black to white gradient showing values from 0 to 1 across the X-axis. To create the repeating tire pattern, add a math node and set the operation to ping pong. Increase the value. This controls the repetition. The value should be half of the lane width. For example, if your lane width is 3.5 meters, use 1.75 as the value. The modifier settings, you can also set the shoulder width to 1.75 meters for symmetry. Next, add a color ramp node to adjust the brightness and contrast of the tire marks. Increase the brightness slightly to make them more visible. Now, let's add some bump detail to the road for extra realism. Go to the shader editor again. I'll use a texture to control the bump effect, mapped using the same UV road coordinates we created earlier. Load your bump texture, plug UV road into its vector input, and connect it through a bump node into the normal input of the principled BSDF shader. You can now delete any unnecessary texture nodes you no longer need. That wraps up this part of the tutorial. Thank you everyone for tuning in and following along. If you enjoyed this tutorial, don't forget to like, subscribe, and leave a comment if you have any questions. See you in the next one.